Everyone, and welcome to Math with Manny. It's specifically with AP Calculus, right? The goal obviously is as we start off with AP Calculus and go through the ranks from lesson by lesson, this will give you an opportunity to kind of just look through the videos and give yourself a bit of a refresher as you're learning through the content and at the same time being able to practice a lot of the content as well. And we're hoping that, along with the notes that I would give you and along with the use of Desmos and other pieces of technology to give you that opportunity to just give you a bit of a refresher with the content and at the same time give you a chance to practice some problems that I would give you as well based on the practice problems and the answer keys that I would give you, and at the same time to help enhance your levels of abilities through AP Calculus. Now, the biggest thing with AP Calculus, AB specifically, is that they want you to understand completely algebra, right? Calculus, they only use so much of it, but at the same time, if you understand algebra, calculus will not be as bad because they do a lot of algebraic techniques when it comes down to it, right? So in this case, what we're going to be doing for the next few lessons, right? And my goal will be to put a lesson per day of every new content. Right along with that, a lot of practice problems and some review as well that we can certainly go over. But in this case, what I definitely want to go over is just a review to get you guys ready for AP Calc, right? So if you look at this first lesson here that we'll be doing, this will be called AP Calculus Lesson 1, Graphs and Models, right? They love graphs, but the biggest thing is they want you to sketch the graph quickly. But before we even do any of that, right, our biggest goal is for you to understand what graphs look like and how do we make those applications on our graphs, right? So if we look at this example here, if we want to sketch the graph of y equals x squared minus 2. Well, without even teaching you anything, we're going to go back to our Algebra 1 or pre-algebra days, right? And the biggest thing that the only way at the moment on how we know on how to graph is to, well, create a table. We would denote the x values as the input and the y values as the input, right? Input is what we put in, y value, and output is what we get out from the input, from the equations or functions that we'll be working with, right? Now, if we look at this particular function here, x squared minus 2, we know for a fact that this is going to be a parabolic function or a quadratic function, right? Where that will create a parabola. And the best way that I can tell you in which we can kind of figure out what the points look like is if we plug in values for x that are between -2 and 2, including -2 and +2. So what we're going to do is we're going to plug in each of those values to figure out what the answers are, and then from there, plot them into this graph that I have here on the far right side. Okay, so if I plug in -2, right, this is your input. What we're doing now is changing not 0, but -2 for x to figure out what the solution would be, right? So in this case, we have -2 squared minus 2, which will give us 4 minus 2, which will be 2, which means now the ordered pair is going to be -2 for x and then 2 for y. Okay, we're going to do the same for -1. So -1 squared minus 2 is equal to 1 minus 2. Remember, two negatives make a positive, which is why it changes to a positive here. We then get -1. So we get -2 and then, -1 and then -1. When I plug in 0, I just get 0 minus 2, which is going to be -2, 0, -2. Same for 1 and 2. I get 1 minus 2, which will be -1. And I get -1, comma 1. And then lastly, I plug in 2, which is 4 minus 2, which is 2, in which case I get 2, comma 2. Okay, oh, my apologies here. That should be a negative right there. My apologies there. So now what we're going to do here at this point is we're going to go ahead and plot these points, right? Now that we've got all 5 of these points, what we're going to do is plot them all, right? I'm going to zoom in just a little bit more so that you guys can see everything here. Actually, it's a lot better as a matter of fact. So let's go and plot the points. So we've got all 5 of these points here, and then from there we can kind of see what the graph will more or less look like, right? So we've got -2 for the x, and then +2 for the y. We're going to plot that point. We look at -1, then we plot -1. We get 0, we get -2, we get 1, -1, and then 2, comma, +2. And then from there, we can go ahead and kind of just sketch a quick synopsis of what that graph will look like. So it's a parabolic shape, in which case it opens upward, right? So that's all we know for right now at this moment, right? To figure out what the graph will look like based on just plotting x's to find our y values, right? Now, there's going to be a bit of a kicker here. What if we're given another graph to work with. And let's say we're given this function here, 1 over 20x multiplied by 19 minus 10x cubed plus, plus x squared. Well, a table is not going to work out, but what we can do is use technology to make this happen. And the most common tool that I'll be using throughout the time here, as I'm showing you guys videos and content, is the idea of Desmos to see what this graph is going to look like. So what I'm going to do here is I'm going to share with you my screen. What I'm going to do is use Desmos to plot what this graph should look like. Okay, so as I plot this graph here, okay, 1 over 20. Oh, my apologies there. 1 over 20 multiplied by x, and then 19 minus 10x cubed, and then plus x squared. And then as we close this here at the end, we can put equals y here for the sake of argument. Here is what the graph will look like. Now, basically from here, as we use Desmos, here are all the values of x in which we get an answer here, right? So we've got a point that peaks right here. We have 2 points that cross the x-axis right here and right here. We obviously have our 1 point that crosses the y-axis right there as well. And that's all we have at the moment. What we can also do using Desmos is to create a table in this case, right? So let's see how we can create the table here in this case. If I delete the equals y, let's see how we can, yep, there we go. So what we're doing here is we're not putting equals y and just using this as a now to create a table, right? Because what we're doing here in this case is using this equation, right, that was given to that we're trying to type in to figure out what it's going to look like here at the end, right? So what I'm going to do here is just basically press enter to figure out other values for x that will give me solutions for y. And as I notice, as the x's get bigger and bigger, notice how our answers get much smaller, much quicker. The same also goes for the negative values as the x's get smaller. So let's if I plug in -3, -4, -5, -6, -7, -8. I notice that the answers are also getting smaller and smaller as my x's also get smaller and smaller, right? So we've got the behavior, what the graph looks like based on just using the table alone, right? That's all we know at the moment. However, right, as we move forward with our mathematical content, right, we need to find specific values that will help us denote important points of of any function or any equation, right? So let's go back to the notes here and let's take a look at the next piece here. So if I go to advanced and go to second camera, and here we go. What if we are looking now for the intercepts of a graph? Well, first things first, if I want to find the x-intercepts algebraically, right, we can look at a graph and we can see where they cross on the x-axis or the y-axis. But in this case, if I want to find the x-axis, x-intercepts algebraically, I need to replace 0 for y. In other words, I'm working with the opposite. And then from there, we need to then find all the possible value of x-intercepts. So we need to find for this example here, find the x-intercepts of this function of y equals x cubed minus 4x. Well, first things first, we're replacing 0 for y, crucial. So this y is going to change to 0. Okay, we have 0 equals x cubed minus 4x, right? Now, if you've never solve for x before with this, right? What we want to make sure is that all the x's are on one side and then everything else is on the other side of the given equation, right? So since we've got 0 equals x cubed minus 4x, let's now move on to the next piece. And then with this next piece, we now need to find all the possible x-intercepts, and if we can use Desmos to see if the x-intercepts will match, right? Well, we're given 0 equals x cubed minus 4x, and if you notice, I have two x's, or rather two terms that have an x in it. And what I can do is both of these, I can factor out an x from both of them, right? So I have 0 equals x multiplied by x squared minus 4. Now notice how now I have two factors, and both of these factors are going to equal 0. So what I'm going to do here is set both of them equal to 0 to figure out what my values of x will create x-intercepts, right? So in this case, I've got 0 equals x as well as 0 equals x squared minus 4. Well, the first one is just x equals 0. We're done with that. How about this one here, right? If I want to solve for x, I can do it in two ways. I can figure out what they it's two factors that create this, or I can just set it equal to x automatically, right? Let's go ahead and actually factor these both out, right? This is your perfect square trinomial, essentially, in which we can square both of these, in which we can create our two factors. We have 0 equals x minus 2 multiplied by x plus 2, right? And if I were to multiply these out using the FOIL method, sorry, I would then get x squared minus 4. So in this case, I've got 0 equals x minus 2, as well as 0 equals x plus 2. My two values of x that will create x-intercepts are 2 equals x and negative 2 equals x, as I set these both equal to x at the end, right? So my ordered pairs would be 0, 0. Here would then also be negative 2, 0 for this, as well as 2, 0 for the other one. Let's go ahead and use Desmos just to be safe, okay? So if I go back to Desmos, okay, and then figure that out here at the end. Let's go and do it. I'm going to delete this here. I've got y equals x cubed minus x. Oh, sorry, minus 4x, my apologies. And if I notice, I've got 3 x-intercepts. First one here, second one here, and the third one there, right? So by using the algebraic methods, I can then set y equal to 0 to figure out what my x-intercepts are. And there could be more than one. There is only one y-intercept allowed usually. Okay, and that's the key word, usually. Okay, so in this case, if we look at the next example, and we look at the graph here, 0, 0 would be the y-intercept, right? So if I go back to the notes here, go to second camera and share. All right. Well, let's find the y-intercepts, right? To identify the y-intercepts, we need to replace 0 for x to identify all the possible y values that identify the y-intercept. So for this example, find the y-intercept of the function y equals x cubed minus 4x. Well, I'm going to replace 0 for x. I get y equals 0 cubed minus 4 times 0. And all we're going to do at this point is just solve for y. Well, I get y equals 0 minus 0, in which case it is going to be 0. And we've already seen in Desmos, right, that the y-intercept was 0, 0. Okay. Moving on now to the symmetry of a graph, right? When we think about symmetry, we're thinking about how both sides, if I were to cut it in half, would be exactly the same. Now, here is the kicker. When we talk about symmetry, when it's respective to an axis or the origin, okay, this is going to be the kicker, okay? And what I tell my students is we always want to think opposite, okay? So if you look at the symmetry of a graph, right? The first one is if we have got the symmetry with respect to the y-axis, right? This means the x value would be its opposite. And how that would look, if I were to draw any xy plane, does not matter how it looks at the end of the day, right? If I were to put a point right here, let's say we call this point right here x comma y. And if we're reflecting it across the y-axis, right? Notice how our x is left and right, our y is up and down. If I were to reflect it across the y-axis, right, putting it on the other side, it's reflecting left and right, but notice how the x value now becomes its negative. So now I've got negative x comma y. The y always, not it's negative, it's to be more specific, it's opposite. That's the kicker. The y stays the same, but then the x value will become its opposite. If I'm reflecting across the x-axis, well, I'm going to go up and down this time, but notice how the y becomes its opposite now, right? So if I were to do a quick graph, yet again, call this x and y, okay? And I want to put a point right here. So let's call this x comma y. And if we're reflecting it across the x-axis, right, notice how the x value does not change, but then I'm reflecting it across the x-axis, meaning now it becomes its opposite, right? The y value, not the x, as the x will stay the same. If I'm dealing with symmetry with respect to the origin, okay, this one's going to be a kicker here with this one here. Notice how now both become its opposite, right? Because I'm reflecting across the line y is equal to x, right? The line y equals x is just a straight line that crosses through the origin right here, right? I'm not going to draw it per se of what it looks like based on this, but if I were to draw a much bigger graph to give you kind of a better visualization, right? If I were to plot the point right here, x comma y, right? What I'm doing now at this point is I'm reflecting it across both. So let's call this x and y, just for the sake of argument, right? Here's negative x, and then here's negative y, right? In this case, the new point, as it reflects, let's say if I were to draw the point like this, right? Here's the line y equals x, right? Notice how it's now flipped over to the other side, right? Where now your new point is negative x, negative y. In other words, both values now become its opposite, okay? Y-axis, the x becomes opposite. X-axis, the y becomes opposite. Across the origin, both of them become its opposite. We've got a few more examples here to look at, so let's take a look here. Okay, so for this example here, I want to determine if the function y equals 2x cubed minus x is symmetric with respect to the origin. Now, we could graph this, right? But what does this mean? And if I want to do this algebraically, right? If I were to plug in the value, the opposites, I would get the exact same equation. Okay? If I plug in negative x and negative y, I should get the exact same equation. It's basically what it's saying. Okay? So if I plug in I should get the exact same equation. And that's how I can show that it would be symmetric with respect to the origin. So let's do it, right? So let's plug in negative y is equal to 2 multiplied negative x to the third power minus negative x. Okay, so I have negative y is equal to negative 2x cubed and then minus negative x. Okay, this is where it gets a little bit tricky. Notice how both of these terms contain a negative. I can actually take it out. And watch what's going to happen here. Right, this negative is a minus sign. It's still a negative, but I'm working with this negative that's next to this x. I'm not going to change that to a positive. And the reason being is because if I divide both sides by a negative, they both change to positive. So therefore, I get y equals 2x cubed minus x, and voila, they are symmetric to the origin because this equation is the exact same equation of what I started with. All right, the last one here. Finally, let's find all the points of intersection if given two graphs. This means we have to determine what the x and y values are exactly in either two or more equations. So for this example here, I want to find all the points of intersection of these two functions, or rather these two graphs. Well, what do you notice, right? They both contain a y. And you should be able to kind of figure out, well, if they both contain just a single y, right? I need to set both equations equal to y to have y by itself, and you're going to see why. So we're then going to set both equations let's do so, okay? And what I'm going to do is I'm going to split these up, right? I've got x squared minus y is equal to 3, and then x minus y is equal to 1 on both sides. X squared minus y is equal to 3. as well as x minus y equal to 1. Let's get y by itself on the first one. Well, I'm going to move the y to this side. Okay, I've got x squared is equal to 3 plus y. Subtract 3 from both sides. I get x squared minus 3 is equal to y. On the other side, let's do the same thing. X is equal to 1 plus y. Move the y, the 1 over. X minus 1 is equal to y. Notice how now they're both equal to y. Since they're both equal to y, we can set both of them now equal to each other. In other words, the x's on each side equal to each other to first find the possible values of x from both functions. Let's do so. We've got now x squared minus 3 is equal to x minus 1. Now, the easiest way that we can do this here at this point is, let me actually check out the notes here. Okay, so yeah, from here what we're going to do is then find all the possible values of x, okay, from both functions. What I'm going to do here at this point is I'm going to set this equal to 0 because I can create a quadratic equation from this and then factor it out. I'm going to move the x over here and then the 1 over here by subtracting and adding. I've got x squared minus x and then plus 2 equal to 0, right? If I were to factor this out, two numbers that multiply to positive 2. Oh, actually not, my apologies here. It should be a minus 2. Whoo, caught that one there. Good. Two numbers, because it wasn't factoring here. Two numbers that multiply to negative 2, but then add to negative 1, right? This is coming from algebra, right? This is where we use the diamond method. Two numbers that multiply to negative 2 by multiplication, but then add to negative 1 by addition. Well, it's going to be negative 2 and then positive 1. So it factors out to x plus 1 and then x minus 2. Setting this equal to 0, I know my two values of x. I get x equals negative 1 and then x equals positive 2. Those are my two x's. But now what I need to do is use these two values of x to then find my values of y at the end. And I'm going to plug these into any one of these two equations I choose to find my values of y. Okay, so let's go. And probably the easiest one, by the way, would be this here, because there's no squaring or moving many terms around at the end. So I'm going to plug in negative 1 and positive 2 in for x to find the values of y. So let's use the easiest equation. So we're going to use the x minus y equal to 1. We've got the first one. X equals negative 1. Let's do that first. Okay, negative 1 minus y is equal to 1. Add 1 to both sides. Negative y is equal to 2, but then y would be negative 2. So my first ordered pair would be negative 1 and negative 2. For the other one, for x equals 2, I've got 2 minus y is equal to 1. Let's move the y over here, or the 2 over. Negative y is equal to negative 1. I've got y equals positive 1. So when x is 2, my y is going to be 1 at the end. And there you go. Those are my two intersecting points. Let's go and prove it by using Desmos to finish things off here. Okay, so by using Desmos here at the end, just for the sake of argument, so we've got x minus y equals 1. And then the other function, the other equation, was x squared minus y is equal to 3. We're going to find out that they both do cross at those points that we talked about, negative 1 and negative 2, as well as 2 and positive 1. Right? This concludes the first lesson. I'll be putting practice problems and solutions for those practice problems. I'll do about 10 for each to kind of give you an idea of what to work with here. And then from there, we'll have one lesson to work on every single day. For every single day, about up to hopefully 5 days a week to build the full packet for AP Calculus to get you guys ready for AP exams. So thank you guys for watching, and we will see you for the next video. Thank you so much.